Graph the exponential function based on the transformation from the parent function, and then identify domain and range. We could also ask you horizontal asymptote transformations. I think those are the main things. So there's a lot to write down at the top of your page. I encourage you to write down the important things that you tend not to remember. Either something that's so quick and easy you could write at the top, or a formula you know you're going to get, or a little reminder to yourself that you need to remember to study. Don't bother writing everything. Pause now and write it, and I will do the same. On the top here, I have written down the formula and important points to remember. Now, combining this area, this, if it's like below, and where the k goes up and down, that's going to affect my range. Now, I know that my domain is all real numbers, and my range is going to be clear once I actually graph it, so I'll wait to answer that question. Now, what I'm going to do is I'm going to try to write the parent function over here. So we always start with a asymptote. The original asymptote is over here on the x-axis, dashed because it's not actually part of my function, but it's an important piece of it. Now, my parent function is y equals 2 to the x. Now, you can make a table, x, y, and we always plug in -2, -1, 0, 1, 2. Now I'm going to opt to just write put the points in, and actually I'll show you for these purposes. When you get really good at this, you can go straight to the graph and skip this. So that's what my table looks like, and that is what my points look like for my parent function. Now in blue, I'm going to write the transformation. Now we always put the A over here. This is my A graph. So what is my A? It is 3. And so what does that 3 do? Well, it's a vertical stretch by 3. That means every single one of my height, I'm going to stress that word, my height is going to be tripled. So move that out of the way because it'll be important. So this is the height of 1. I always kind of start at 1. The height of 1 is tripled, so it goes up to 3. This height of 2 is tripled, goes up to 6. This height of, that's 2, tripled to 6. 4, tripled to 12. It's nice to give you all that space. Now this is a half. 1/2 tripled is 1.5, right? If I had half a pizza pie, and I had 3 of those, I have 1.5 pies. And this is going to be 3/4 because it's 1/4 tripled is 3/4. Now it's still going to, follow the same shape. It's just going to go up taller, faster. So I'm going to see if I can make as smooth of a curve as possible, approaching the asymptote but never hitting it with arrows, and that is my shape. Now what's going to happen is I'm going to take my asymptote and I'm going to move it, the transformations. Let's write down the transformations. I have a h of 4 and a k of 6, and I see they're both negatives. So I'm going to make a little transformation, sticky notes to myself, over here in, let's call it green. So I see h of -4 means I go right 4. And another one, k of -6 means I go down 6. So the first thing I'm going to do is, that's what these transformations are doing. The first thing I'm going to do is to draw my asymptotes, or my new axes. So the most important asymptote is this. The most important axis is the asymptote, the horizontal asymptote. So it goes down 6. It started over here, and it's going down 6 over here. Computer's lagging on me. And then imagine the x-axis. Imagine the x-axis moving as well. Well, the x-axis starts over here. It's going to go right 4. Let's see what it looks like when it goes right 4. Now I'm going to transfer each and every single blue point, over to the right using my new axes. I'll show you the first one. The first one is at 0, 1, 2, 3. I want my new axis. I put a dot at 0, 3. Those are my points. You can pause if you need to, and I'm going to draw a nice curve through them if I can. That's my graph, horizontal asymptote, and range.